What is going on, guys? Welcome back. In this video today we're going to learn how to turn Postgres into a vector database in order, for example, to store embeddings from large language models. So let's get right into it. Alright, so we're going to learn how to turn Postgres into a vector database in this video today. And we're going to do that by using PGVector, which is an open source extension for Postgres. And why would we want to do that? For example, to store embeddings created by large language models in order to build a recommender system. That would be one use case. You have a bunch of different movies or books or items in a store. And what we do is we feed the information in textual form as a prompt, so to say, to a large language model. And the large language model returns a high dimensional vector. And this vector is created in an intelligent way so that the different vectors, if they are similar, if the items that are embedded, so to say, are similar, they end up quite close to one another in the vector space. Whereas if they are very different, they end up further apart in the vector space. That's the basic idea of creating embeddings using large language models. And you don't need to use a pure vector database like Face, for example. In order to do that, you can do that with Postgres if you install the PGVector extension, which is what we're going to do in this video today. So the goal is to get some items, create some embeddings using a large language model. I'm going to use the OpenAI API, so GPT. You can also go with an OLlama, Llama 2 model, depending on if you want to run this locally or using some API. It doesn't really matter. The only thing that you need to consider is the dimensionality. So the different LLMs will return vectors of a different size, of a different dimension. So this is something that you have to take into account. But besides that, it doesn't really matter how you do it. You just have the embeddings, and we're going to use PGVector to store the embeddings and to perform a similarity search for example, a recommender system. All right, now it's not going to be part of this video to set up Postgres, so I assume you either have Postgres installed already or you know how to do it. So I'm not going to go through installing Postgres server and setting up a user and granting the permissions and so on. I assume you already have this running, or you don't want to follow along, or you know how to do it yourself. I'm not going to go through the steps here. But if you have Postgres installed already, what you need to do is you need to install PGVector on your system. So you want to go to the GitHub repository. You will find a link to it in the description down below. And you want to go and clone this repository. So either git clone or download the zip file and extract it. And then depending on your operating system, you just run a simple command. On Windows, you run this call command. And on Linux and Mac, you go into the repository, you run make, and you run make install. In my case, as it already says here, I needed to run sudo make install, so it needed some elevated permissions. And then you basically have PGVector on your system. Now, this doesn't mean that you already have it in your database, so you need to do that separately. But once you have this installed, what you want to do is you want to open up a terminal and create a new database, or use an existing one if you want to. So in my case here, this is going to be, let's call this create vector DB or vector tutorial DB, whatever. I just create a new, not create, sorry, create DB is the command. Create DB vector tutorial DB. This is going to create a new Postgres database. And what I want to do now is I want to connect to it. Now, of course, this means you have to have the PG config file set up properly so that you can log in and all that. But again, this is not a video on Postgres. Just connect to the database the way you do usually. So in this case, I'm going to go with PSQL host is localhost, and then username is Postgres, and DB name is vector tutorial DB. And then it's going to ask for a password, in my case, Postgres. And now I'm in the database here. So I can look at this. I don't have any tables here. And what I want to do now is I want to create the extension. So I want to actually enable the vector extension. So what I do is I say create extension if not exists vector, like this. So this command here, create extension if not exists. Let me just make this a little bit larger for you guys. If I run this now, this creates the extension vector, and now my database supports vectors. And now I can create a table that can store items that can store items with vectors, or that can store vectors in the table. So I'm going to say now create table items, for example, and now I can define the usual fields. I can say I want to have an ID, which is a serial So an auto increment primary key. I want to have a name, which is going to be the text, or I can say, maybe let's call this content text. And then I want to have the embedding. So the embedding is going to be a vector. This is now where we need the plugin or the extension. And this vector has a dimensionality. Now, if we use Llama 2, I think we get 4096 as the dimension. If we use OpenAI's GPT, we get 1536. So depending on the language model that you use, make sure you know what the embedding dimensions are, or the size of the vectors that are the embeddings are, and then create the table with this dimensionality. So run this, create table. We now have the table. Now I can quit, I can exit, and this database now can store the vectors of this size. All right, so what I want to do now next in Python is I want to connect to this database, create some embeddings, and store them in the database. So what I'm going to do for this video here is I'm going to use some very basic data just to showcase the concept here. I think you already know, or a lot of you guys already know how this works. I just created some basic texts that have some similarity. I just created them in a way that shows that the similarity is not determined by specific words in terms of the words are similar, but also on in terms of the meaning. So I'm going to showcase this here. But first of all, we want to open up a terminal and install the following packages. So pip3 install. We want to install psycho pg2, which is for Postgres. We want to install NumPy, and we want to install LangChain. So these are the three packages that we need in this video today. And then we're going to start by saying import psycho pg2, import NumPy as np, and from LangChain embeddings, import OpenAI embeddings. Now, this is just because I'm using the OpenAI embeddings. If you're using different embeddings, you want to use a different class here. And now I'm going to copy paste here my prepared text. You can use whatever you want here. You can craft your own stuff. You can load a data set. In my case here, what I'm doing is I have a couple of configurations of computers. So I have a desktop PC, a laptop with different operating systems, Manjaro, Windows, Fedora, Ubuntu, with different GPU brands, with different CPU brands, with different RAM sizes, and with different SSD sizes. So very simple, and I want to find now to a given text the most similar model that I have already. Now, one more import here, which I forgot, is the OS import. This is core Python. And what we're going to do here now is we're going to load the API key that is needed. In my case here, I have it stored in a text file. And we're going to load the API key from this text file here. So what you need to do for this, of course, is you need to go to the OpenAI platform. You need to go to settings and create an API key. It's basically something that starts with sk dash and then some long string. And what I'm going to do here now is I'm going to say API, or actually I need to load this as an environment variable. So os.environ, and then in the square brackets here, I'm going to say OpenAI underscore API underscore key. This is important because this environment variable will be used by LangChain to authenticate with the OpenAI API to be able to use GPT. So we're going to set this to, and then open API underscore key in reading mode, read. So this is going to load my API key into the environment variable, and now I can create the embeddings using LangChain. So I can say embeddings is equal to OpenAI embeddings, and then I can say embeddings list is going to be equal to an empty list, and then for text in texts, I'm going to say embedding list append, and then we want to embed the actual text. So embeddings, which is the OpenAI embeddings object here, embed underscore query text, and then we have a list of embeddings created by the OpenAI model, the embedding model. Now, I'm not sure actually which one is used by default. It depends probably on the version of your package, but it's going to use some decent embedding model. And we can also see here, so I can look at embedding list, and you can see I have these vectors, and I can also look at the first element, for example. And I think, is this a list or is this a NumPy array? So if it's a list, we should be able to get the, or actually also if it's a NumPy array, there you go. The length of this is 1536, which is exactly the dimensionality of the vector that we created in a database, or the field that we created in a database. And now what we're going to do is we're going to store these embeddings in our Postgres database. So I'm going to say here now the connection is going to be equal to psychopg2 connect, and we're going to use the following connection string or connection parameters here. DB name is going to be equal to, what did I call this actually? Did I call this vector tutorial DB? I think so. User is going to be equal to Postgres, and password is also going to be equal to Postgres in this case. And then I'm going to create a cursor, which is going to be a connection.cursor. And now I'm going to go through the embeddings list, and I'm going to insert the items. I'm going to insert the items into the Postgres database. So for I in range length embedding list, I'm going to say the embedding that I want to embed or that I want to insert into a database is embeddings list I, and then the corresponding content is going to be equal to the text at this position. So the reason I also want to insert the text into the database is because I want to get, of course, the most similar result, but I also want to be able to map it back to the actual content. So if the database tells me that given a certain string, the most similar computer setup is, or configuration is 5, I don't know what this is unless I also have the text in there. So content is equal to text I, and then cursor execute the following statement. Quite simple. We're just going to say insert into, what did I call it? Items, values, or actually we need to say name, embedding. Actually, I'm still using name because in my prepared code I'm using name. Content, embeddings, or embedding, values, and then we have here a prepared statement, so 2 placeholders, and then we're going to say here content and embedding as a tuple. There you go. So this is just to prevent SQL injections. And then we say connection commit, and then we say cursor close, and then we say connection close. So this inserts the items into the database. Now I'm not sure, do I have my terminal still open? No, this is just my Jupyter notebook. I could actually connect to the database and see if we can already see this stuff in there. So PSQL host localhost, user name is Postgres, DB name vector tutorial DB, and then select everything from items. Did it work or not? Not sure. Let me just double check if I did everything correctly. Insert into items. I think it should have worked. So let's see if the code works. Maybe just the display didn't do this properly, or it wasn't displayed properly. But what we're going to do now is we're going to get a new text, or a new text. And I'm going to say that this is, I'm going to copy paste this again here from my prepared code. This is the following system, and I'm going to explain here why I chose this system. You can see that this is a desktop PC with the Arch Linux operating system. Now, we don't have an Arch Linux operating system here. We have Manjaro, though, which I would consider to be the most similar because, yeah, of course, Manjaro is also Arch-based. And because of that, we're going to say now new embedding is equal to embeddings.query new text and, oh, sorry, embed query new text. And then we're going to say now, I want to find the most similar vector in the database. How do we do that? Well, we do, first of all, a connection again. So I'm going to just copy paste this. We connect to the database again. And then we run the following command. So cursor, execute, and we're going to run this as a multi-line command here as a multi-line string. We're going to say select ID and content from items order by, and now here we're going to use this operator provided by PGVector. We have the embedding, and then we use these double arrows here. So basically these angle brackets with a hyphen in between, and we're going to say now here %s and then : vector, and we're going to say limit 5, for example, to get the top 5 results. And this here now is going to be our new embedding. So the basic idea is we want to select the ID or the IDs and the contents from the items table where the embedding of this particular object in a table is the most similar to the vector that we pass, and we specify that this is a vector by using : vector. And this here is basically a similarity search. Now what's the problem here? Oh, this is a tuple, so we need to pass a comma. And then we can get the results by saying results is equal to cursor fetch all. For row in results, we can print the row. And this did not work as expected, so let me just double check what I did wrong here. Okay, so I figured out what the problem is. It shouldn't be text I, obviously, but texts I, plural, because we don't want to have the ith character of the text that was processed here in the last iteration. We want to have the ith element of this text list, so we need to do it like this. Then we need to run all of this again. The problem is, of course, that this is going to still give us the old elements, which is why we need to actually truncate the table. I think for this, though, we need to say connection close first. And then we're going to say truncate table items. And now we should have nothing in this table. So I'm going to run actually all of this here again. There you go. And we see that Manjaro is the most similar, or this computer here with Manjaro is the most similar to our computer, even though the Ubuntu and the Windows system have the exact same RAM size and GPU brand and CPU brand and hard disk or SSD size or capacity here. But of course, Manjaro is the most similar because it's an Arch-based distro. We have Ubuntu, which is a Linux-based distro, and then we have Windows, which is not Linux at all. And actually, Linux Mint should probably be more similar. But this is just one example. What we can also do here, I have a second example prepared, is where I want to showcase how this works. If I delete this and I replace it by these texts here, my computer was made by Apple, my favorite fruit is apple, so it's the same word but a different meaning. My Adam's apple hurts, my knee seems odd today, my laptop is running Arch Linux, my breakfast usually includes berries. Now in this case here, the reason I chose these strings is because, of course, the apple here should be more similar to Arch Linux or to laptop, whereas this apple here should be more similar to berries, and the Adam's apple should be more similar to a knee. So even though the word apple occurs 3 times here, it has a different meaning, a different context, and this should probably be picked up. I hope it's picked up by the large language model. So we're going to do the same thing here. Let me just truncate the table briefly again. Do we have a connection open? I hope not. So let me just truncate the table again. And we're going to input all of these into the database. And now the new text is going to be a different one. The new text is going to be, let's play around with my desktops always run Windows. And if I run this now, you can see that my computer was made by Apple. My laptop is running Arch Linux. This is recognized as the most similar. Whereas if I do something like my dinner would benefit from adding apples to it, then you can see that these two are the most similar. So even though the term apples occurs here, this is the most similar and this is the most similar, the second most similar, and the other apples are less similar than berries because the apple word has a different meaning. So you can see that the embeddings are done in an intelligent way. But this is how we can use Postgres as a vector database to perform similarity search on embeddings. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.